In this video, we will study how to convert from decimal to binary numbers. So far, we have done some examples for converting decimal number to hexadecimal and also converted hexadecimal to binary number. And then we tried to calculate how to convert back from binary to hexadecimal and hexadecimal to decimal numbers. So we are actually dealing with three number systems. And in this video, we will study how to convert from decimal to binary directly without going to the hexadecimal number system. But before that, I want to tell you that how this table is actually created. You may have thought about this in the previous videos. So the idea is really simple. We convert from decimal to binary number and then create this table. So let me tell you how we do that. So let's suppose I want to convert from 4, which is a decimal number, to binary number. So I will follow this method. So I have 4. Okay. So here I will do the division with 2 because we are talking about binary numbers. Previously, we divided with 16 because we were dealing with hexadecimal numbers. So dividing 4 with 2. So let's do that. So I will create this table. So 2 times 2 is actually 4, and we are left with 0 remainder. If you recall, in this hexadecimal number system conversion, we were also talking about these remainders. Okay, so this 2 times 2 becomes 4. Now divide again because we want this number to be less than this divisor, which is 2 over here. So 2 multiplied by 1, this becomes 2. So once again, my remainder is 0. So all these numbers, if you look over here, they are less than 2. So we have converted 4 to our binary number. So how are we going to write this? Is starting from this digit. We will write like this 1, 0, this one, and then we move upwards, so it becomes 0. So 4 in binary number is actually 100. This is not 100. This is 100. Here I have written these 4 digits, so we can simply add 0 over here, so it does not change anything. So 4 is converted to 0, 1, 0, 0, so we can see over here. Similarly, if we are for making this table, we can do all these divisions. 0 is actually directly 0000. 1 is directly 0001 because this is less than 2. For 2, let's do this once again for 2. So it's really simple. 2 divided by 2 is like this. 2 times 1 becomes 2, and then we have remainder 0. So now how I can write 2 starting from this number. So this becomes 1. Then we move towards right and upwards, but there are no numbers. So this becomes 1, 0. So 2 is equal to not 10. Don't call this 10. Call it as 1, 0. And we can see over here, this is 1, 0. We can simply add 00 before that to make it in 4 bits. So similarly, we can do all these divisions for all these decimal numbers, and we can obtain this left-hand side binary number system. And then later on, we can use this table for converting from binary to hexadecimal directly. So let's do one more example. Let's do this 11. Okay. So how we are going to do that? So 11 simply divide by 2. So 2 times 5 is actually 10, right? I cannot do 2 times 6 because that will give me 12, which is larger than this 11. So we will not be able to write remainder as a positive number. So we need positive remainder. So 2 times 5 actually is 10. And after that, we will be left with 1 remainder. Okay. Now, 2 times 2 becomes 4, right? So I can do this. 2 times 2 becomes 4. Again, I'm left with 1 remainder. Okay. And then 2 times 1 is 2. So at that moment, I will have remainder 0. So 11 can be written as 11 in decimal can be written as starting from this number, move towards the right hand side, and then toward the top side. So this becomes 1, then we have 0, then we have 1, and then we have 1 again. So 11 in decimal is equal to 1011. So we can see it over here. So this is how we convert from decimal to binary numbers. Now we will do the examples which we have been doing so far. The values larger than 15. So how do we convert that to binary numbers? So let's go to the next slide. For example, now I have this number, let's say 37. 37, I chose a bit larger value. So how to convert this to decimal number? We know that we have to divide this by 2, right? So 37. There are actually two ways for division. One we can, let's do the method which we did for hexadecimal. So let me do side by side. So 37 divided by 2. This is the method which I used for hexadecimal. So if we follow that method, so 3 is larger than 2. So 2 times 1, I can get 2 value. If I do 2 times 2, then I will be getting a value of 4, which will be larger than this. So I don't need that. So let's do 2 times 1. So I get 2, right? After that, I got this remainder, which is 1 after this subtraction. Now 7 will appear same as it is over here. Now, next what I can do is I can multiply this with 18, right? So 2 times 8, no, not 18, sorry. What I meant is that we will multiply this with 8 to get 16. So this will be 8, so we will get 16. I got this value 1, right? Now 37 can be written as 18 times 2 plus 1, right? Or if I write this in correct order, like the hexadecimal, because I need this 2 over here. Previously, we had 16 for hexadecimal. So now the issue is that now I have to divide this 18 separately again, because what I need is these numbers to be less than 2. It should be either 0 or 1. So I have to do this division for 18 once again and follow this all procedure. So this becomes a bit lengthy. So I will do the division directly over here, which I did in the previous slide. So instead of going through this detailed step, which we did for hexadecimal, this one is much more simple. So I will do this division with 2. So I can see over here, this is 1, this becomes 17. So 17 is closest to 16. So for 16, we can do the multiplication with 18. So this becomes 36. So I will have remainder 1. So you can see in one step, I actually obtained this instead of doing all this mathematics. So now next step, 2. So I know 18 is perfectly divisible by 2. And so 2 times 9 is actually 18, and which leaves 0 remainder. Now once again, 2. So 8 is the closest number to 9. I'm not considering 10 because that will give me a negative remainder. So we don't need a negative remainder. So 2 times 4 will give me 8 and will leave 1 remainder, right? So 2 times 2 will give me 4. It will be 0 remainder. Now I cannot stop over here because this number is still greater than 1 or equal to 2. Because what we need in binary is to have results either as 0 or 1. So 2 times 1 actually becomes 2, and this gives us a remainder 0. So now 37 in decimal becomes, starting from here, move towards right hand side, so 1 0, and then move towards the top side. Okay, so this becomes 0 from this one, then we have this 1, then we have this 0, and then we have this. So 37 in decimal is equal to this number in binary, which is 100101. So this is our result. So in the previous example, which we did for 37, we can do the division similar to the hexadecimal, and then we will have to do a lot of mathematics. But if we follow that method, which I did on the left-hand side, so it reduces the number of steps. So let's do another example. Let's say, let me choose a smaller number. Let's choose 19. Let's do 19, and we will do it using both methods. Okay, so method 1, which I did direct division, and this is method 2, which follows the similar division we did for the hexadecimal. So 19, okay, so I have to do this division 2, so it becomes I think the closest number is 18, which is perfectly divisible by 2. So we get 9. So 2 times 9 is 18. We get one remainder. Now 2 times 4 gives us 8. We get another remainder, right? 2 times 2 gives me 4, gives us 0 remainder. And then 2 times 1 gives me 2, and we get 0 remainder. So 19 is actually equal to 1, then this 0, right? And then after that, this 0, then 1, 1. So this is my answer. Now I will use the method which I did for the division in hexadecimal. In hexadecimal, we had 16, so that number is actually very big number, so division becomes simple using this method, which I will do now. But for 2, this is really small number, so it becomes like really lengthy and time consuming. Method is easy, but it gets like really lengthy and time consuming. So we don't follow this method, and you will see it now again. We did it in the previous slide as well. You will see it again here. So this becomes 2 times, now I know this 2 times 9 will give me 18. So this becomes 1 remainder, right? So now I have to do the division for 9 once again. So 2 times 4. Sorry, I have to write it over here. 2 times 4 gives me 8. So this becomes 8. So this becomes 1. Right? Now I have to do the division of this 4 again. So 2 times 2 gives me 4, remainder 0. Now I have to do a division once again for this. So 2 times 1 gives me, 2 times 2 and 1 gives me remainder 0. 2 times 1 gives me 2 and remainder 0. So now you can see that this division is like repeatedly done again and again, but it gets really confusing sometimes if we have very large numbers. So instead, it is much better we follow this method number 1 for the binary system. Now writing our answer using this method, it's the same method. We can write our answer. We have 1, 0, right? Then we have to write the remainders of each number. So this is 0. From here I have 1. From here I have 1 again. So answers are the same. You can see over here. But it is much better to follow this method because we can clearly visualize everything easily and don't get confused. So this was about how to convert from decimal to binary numbers.